Let's read the question. A bag contains 20 discs, of which 5 are blue. The variable R denotes the number of blue discs in a random sample of 10 discs selected, without replacement, from the bag. The variable S denotes the number of blue discs in a random sample of 10 discs selected, with replacement, from the bag. And the variable T denotes the number of discs randomly selected with replacement from the bag until exactly 2 blue discs have been selected. For each of the variables R, S and T, state whether or not the variable can be modelled by a binomial distribution. We've already looked at the criteria for a binomial distribution today. We've said that there has to be 2 possible outcomes, success and failure. We've said that there must be a set number of trials, n. And we've said that the probability of success, P, must be constant and therefore trials must be independent. So let's look at the 3 variables, starting with R. Are there 2 possible outcomes for R? I'm looking at how many blue discs I get. Therefore, I do have a success and a failure. Success is a blue disc, failure is not. Tick. There must be a set number of trials. It tells me there's going to be a random sample of 10 discs selected. So M for this question is 10. Tick. The probability of success, P, must be constant, and the trial therefore must be independent. In this question it says once they are selected it is without replacement. Therefore the probability of selecting a blue starts off at 5 over 20 and then becomes something over 19, something over 18, etc. So the first one, R, is not suitable for a binomial. And the reason is that P is not constant. Let's take a look at the next variable. The next variable is S. Again, this is looking at the number of blue discs, so there are 2 possible outcomes, blue or not blue, success or failure. Again, it tells me I'm going to do this 10 times. So there is a set number of trials. And this time it is with replacement. So every single time there are 5 blues in there out of 20. That probability of success never changes. So S is binomial with my criteria N is 10 and P is 5 out of 20. Final variable T denotes the number of discs randomly selected. What is success? Success is when I have exactly 2 blue discs, but for every trial I don't succeed or fail, so I do not have a success or fail option. There is also not a set number of trials, I'm keeping going until I get 2. Although it is with replacement, so the probability of success, it is constant, but we don't know what success is, so arguably we'd have to leave that one out as well. So for T, we would say, excuse me, not binomial. And our reason for that, we could go for any of them. I'm going to go with the easiest one and say N is unknown. But I could say we don't have 2 possible outcomes as well. Moving on to part B. This is a slightly strange question as part P doesn't really seem to fit with part A. It seems almost to be 2 separate questions, but all based on the binomial distribution. So let's have a look at B. It says, in a particular country, 15% of adults have brown hair. Use a binomial distribution to estimate the probability that, and then for part I, a sample of 15 adults contains exactly 2 with brown hair. So I have a binomial distribution of 15 adults. Brown hair, we know the probability is 0.15, and we're being asked for that it is exactly 2 people with brown hair. So in this case, we can either use our calculator or we can use the binomial formula. Because it wants exactly 2, it's a precise distribution. So I'm going to go menu, I'm going to go down to 7, distributions, and I want binomial PD number 4. As I only want one value, I'm going to go for variable, where x is 2, n is 15, and p is 0.15. We could alternatively put this in the formula, NCR, p to the r, q to the n minus r. Both will give us the same answer of 0.2856. Moving on then to part 2. Part 2, this time we have a sample of 25 adults, still looking at brown hair. So that changes to 25 but stays at 0.15. And this time we're being asked for 3 or fewer. So less than or equal to 3. This time on my calculator, I need to change it. I need to stay on distributions, but this time I need binomial CD, the cumulative distribution, number 1. And again, if I go into variable, I can say that x is 3 or under, n has changed to 25, and my p is staying at 0.15. 0.47112. Part 3. A sample of 40 adults this time. So binomial 40. I'm still sticking with brown hair. So 0.15. And this time I am asked for at least 5. So the probability of 5 or more. If I just move my calculator so you can see my writing a little bit better. Remember, my calculator can't do greater than, so I have to do 1 minus what I don't want, which is less than or equal to 4. So again on my calculator, I want distributions binomial CD, number 1, where x is 4, n this time has changed to 40, and p has stayed the same. So 1 minus this probability, 26332, which is 0.73668. Just squeeze that on there. Move the calculator out of the way again. Put it over here. So the last one on this part 4. A sample of 50 adults this time. So my binomial's changed again. Still looking at people with brown hair. So I'm still keeping with the same p-value, 0.15. And this time it's another in-betweenie. So I want more than 5, but at most 12. So I'm using that equal to here. So that's going to give me less than or equal to 12 minus less than or equal to 5. And again, I'm going to use the list function this time so I can get both probabilities at the same time. Menu 7, scroll down to binomial CD, but I'm going to use the list options, and this time I want 12 and 5. My n has changed to 50, my p stayed the same, So 0.9699 take away 0.2193. And just to make sure I'm getting the right answers, I'm going to go back to calculate number 1. 0.9699 take away 0.2193. And that is 0.750.